All right, welcome everybody. In this video, we are going to begin working with a new Colab notebook on functions. And there is a link to this notebook in the description of this video that you can open up and follow along the work that we're doing in this video. And we're going to continue exploring R functions. And we'll dig a little bit deeper and talk about how we can create our own functions in R and build on our own understanding of working with functions in R. And so just recall that functions in R, these take some inputs. They might just be a single input, or there could be multiple inputs. We call these inputs arguments. And that could be a value, it could be a vector, it could be multiple values, multiple vectors, multiple data frames. There could be options that we enter. These options are exactly that. They might be optional. There are settings that we can set and so on. There are certain default settings for some of these options, and we can tweak those options. And we've been talking about how we can open up the help documentation for functions and explore the various options and defaults that are being used and tweak them. And so that's always a possibility for these built-in functions in R. And so here's a dictionary of some really useful functions. This is by no means comprehensive. There's a huge amount of functions in R, and as you have certain needs for certain contexts in R, there's plenty more functions. Obviously, these are kind of the basics to get you going. We've been working with some of these functions already, just to illustrate how they work. So I want to kind of pick up at this point, and then we'll begin kind of writing our own functions in a moment. So let's kind of just begin showing how these work. Let's define a vector z. So z is going to be a vector of the first 10 integers, 1, 2, 3, 4, 5, 6, 7, all the way up to 10. So I'm just going to run this code cell. And if this is the very first time you're running this code cell, you're going to get this warning that says like, hey, this is a notebook, which is not in Google. This is in GitHub. Do you want to run this? You can just click the yes, run this anyway. And it might just take a second if this is the first time you're initializing this notebook. But after you run this code cell, this is going to create this vector of integers. It's going to store it to this object that we called z. And because I have this inside of a set of rounded parentheses, that's why it's also being printed to the screen. So we can see what this vector z is. And when I apply a mathematical operation to a vector, so for example, if I were to apply the mathematical operation add 1 to the vector z, then what R does is it applies this operation to every single element in the vector separately. So now what this did is this created a vector, a new vector that added 1 to each element in the original vector z. I didn't store this vector anywhere. This is just printing this to the screen. But this took the first element, added 1 to it, the second element, added 1 to it, and so on. So this created a new vector by adding 1 to each element in the original vector. And that's how these other more fancier functions work. So if I apply the function exp to the vector z, this exponentiates each element in the vector z separately. So it applies the exponential function to 1. So it's going to take e to the first power, and that's where this comes from. Then it's going to take e to the power of 2, and this is e squared. And this is e to the third power, e to the fourth power, all the way up to e to the 10th power. So it applies this separately for each element. So in goes a vector, out goes a vector. The log function in R, as with many other programming languages, log actually means ln. So I'll just put a comment here that this is the natural log ln, not log base 10. So just watch out for that. So when I take and apply log to the vector z, it's taking log of 1, which is 0. And it's taking, it's taking the natural log of 1, which is 0. And then it's taking the natural log of 2, which is where this thing comes from. And then it's taking the natural log of 10 at the very end, which is where this comes from. Okay, so this is the natural log, not log base 10, although this might seem like how on paper you write ln for natural log, and you might write log for log base 10. When we program in R and we type log, that means natural log, log base e. And if you don't believe me, if I take the natural log of the exponentiation of z, right, the natural log should undo raised to the power of, the natural log undoes the exponentiation function. So these two should undo each other. So if I compose these two functions, I should just get back the original vector z, which I do. So that's great. So now hopefully you believe me that the log function in R is actually the natural log function. If for some reason you ever do want to do a log base 10 in R, then that would be log 10. So you put a 10 afterwards to get the log base 10. So log base 10 is not the inverse of z. So these two operations actually wouldn't undo each other. But what it would undo would be raised to the power of 10. So these two operations would undo each other. And you can see, okay, log 10 is the inverse operation of take 10 and raise it to the power of z. Okay, so the point is natural log is log, log base 10 is log 10. Okay, so back to our functions here. Let's say I want to store this result, which was the log of z. So z was this vector of integers 1 to 10. When I took the log of that, we got this kind of funky looking vector of long decimals. So let's say I want to clean that up and round each of these to 1 decimal place. A very nice function, useful function in R is the round function. So this takes 2 arguments now. So far we've been working with functions that have 1 input. This takes 2 inputs. First is numeric vector, which is now the log of z. And second is a number, is an integer, which is like, to how many decimal places do you want to round these values? So I'm going to take and round this, each value in this vector to 1 decimal place. I'm going to store that result to a new vector that I call y. And let's just print that out and see what that looks like. And that's just a bit nicer to look at than the log z that we had up top. Okay. And now I'm going to go ahead and take a look at the median value of this function. Okay, and so now let's apply a median function to this vector y. So far we've been applying functions, notice, to numeric vectors, and we've been getting outputs that are vectors themselves. The median function is different in that when I apply the median to this vector, notice the output now is no longer a vector. The output is now is a value, just one number. So here we've got this vector y. Y has an even number of elements. It has 10 elements in it. So when I take the median of this vector, if it has an even number of elements, the median is going to be the midpoint between the two middle values, right? So that's where the 1.7 comes from here. So the median function takes a numeric vector and returns a numeric value as the output. The mean similarly does the same thing. It takes a numeric vector, returns one numeric value, which tells us the average of those values. Standard deviation does the same thing. It's telling us something about the spread of the values in that numeric vector. Great. The structure function, this is a different type of function. We can input air quality is a data frame in R. This is built into R, so you don't need to load any packages to access the air quality data frame. So this code cell will run. You don't need to load any package in this session. But the structure function works not just on like a numeric vector. I can input a data frame into this function, and the output is not a vector. The output is not a number, but the output is a summary of what is happening, what is the structure of the air quality data frame. So the point here is that functions are quite flexible in terms of like what they take as inputs, how many things they take as inputs, and what sorts of stuff we get as outputs. And it might vary as well. So for example, if you recall the plot function that we saw earlier, the plot function gave a different output depending on what we input into the function. When the vector was a factor, it created a bar plot. When the vector was numeric, it created an index plot. Sometimes it was a scatter plot. Sometimes it was side-by-side box plots. So depending on the structure of the input, that same function might generate different output. And the length function is a similar type of function. If I input a data frame into the length function, right, it's telling me the length of air quality is 6. And it's telling me how many columns are in the air quality data frame. It's telling me how many variables are in the air quality data frame. If I input a vector into the length function, so air quality ozone is a column from this data frame. So it is a vector. When I input a vector, a one-dimensional thing into the length, it just tells me how many elements are in the vector. So when I input a data frame, it's telling me how many variables, how many columns are in the data frame. When I input a vector, it's telling me how many elements are in the vector. So we're getting different output depending on the structure of the data type or the data structure of the input. The mean function, we ran the mean over here on a numeric vector. What happens if I try and take the mean of the data frame? Over here, I'm getting an error message when I try to take the mean of air quality. And it's telling me the argument, the air quality, this input is not numeric or logical. And if I'm looking at this, well, all of these variables, they are numeric. I would disagree with it there, but the problem is that lots of these variables, or at least some of them, seem to have missing values. There are NA values over here. So for example, even just trying to calculate the mean value of ozone, right? I'm getting a problem. Ozone is a quantitative variable. It's a numeric variable, but it has missing values. So it's giving me an error message. And that's something that you actually are asked to think about how to fix on your first homework assignment. So I won't ruin that fun for you. But for example, if I were to try and do this for day, I don't think day has any missing values. So for example, taking the mean of day, there's no problems here because day has no missing values and we're able to get the mean of that variable there. Okay, so I will stop this first video here, just giving us a little introduction into functions, what sorts of things go in, what sorts of things come out, and then we'll start to dig a little bit deeper into how we can define our own functions in R. Thanks, everyone.